Hey everyone!
Today we're going to talk about reservoir cladding, or brick and stone.
We're going to start off watching yet another video by Matt Reisinger, and in this video he's actually going to show us one of the houses that his company is building, and he's explaining the details for stone and brick cladding. Okay, so he starts off talking about how durable stone is, and he says it's going to be still standing there for 100 years.
Yeah, I mean, think about all the ancient Roman buildings and Greek buildings and
the castles in Scotland.
Yeah, it's all made of stone.
Yeah.
So it's
But that's not a cladding though. That's solid stone several feet thick. Right? Those walls in ancient.
Yeah, they're definitely feet thick
as
opposed to a cladding brick that's about 5 inches or so.
Yeah.
So yeah, he's talking about how durable it is and
the specific system that his company has designed to do, because everyone does this differently. Yeah, and so the system that they did is completely different from the next person down the street, how they're going to install stone.
Yeah, and like with most of his work, he always goes the extra step, and he's using this eggshell
dimple mat
decoupling material. Yes, that's going to keep a consistent inch air gap, which is the most important thing whenever you're doing a brick veneer.
So actually he says that when you're doing a brick veneer, you need an inch thick air gap, but when you're doing stucco and stone, you don't need a 1 inch air gap. But he's choosing to do that with this project, just to allow vapor to evaporate or dry out in that space behind the brick, behind the stone.
Because we mentioned that it's called a reservoir cladding, and that is because these materials soak up so much water and they have to release that water somehow. So you have to have that air gap, and you definitely have to have that WRB behind your stone in order for all that water that's going to move through to be able to escape.
Yeah. So he actually also used mineral wool insulation as a continuous insulation over his sheathing. Right?
Yes, he used a mineral wool and then a Tyvek, right?
A form of a form of weather barrier.
He didn't use Tyvek?
He didn't use Tyvek.
Oh,
no.
okay. So some sort of house wrap.
Yeah. So he's saying that the insulation, the R8 mineral wool insulation that he used, that it helps in avoiding a large temperature difference between the outside and the inside. So for example, this house is built in Texas. So on the outside in summer it's very hot, and the inside it's very cold. So he's avoiding having a single plane at that exterior wall where water can condense because of that the temperature differential.
Mm-hmm. So here he's showing the dimpled mat that allows you to decouple the brick from your sheathing and your house wrap.
Yeah, and it also has this fibrous extra backing in front of the mat.
Mm-hmm. Yeah, and that's often because when the masons lay the brick or the stone, they put, as he's showing right here, a lot of mortar gets behind that brick and stone and fills up that 1 inch air gap. So with this decoupling material, this dimple mat, you get that consistent 1 inch air gap throughout.
Yeah,
even if they do.
At least.
Yeah, even if the installation is sloppy.
He likes using all these one-off high-end materials.
I mean, I guess he does custom homes, so he's not a large-scale builder. He's not going to be doing hundreds and thousands of homes. So
but he gets to experiment with all the latest materials and technology, which is very exciting.
Absolutely, yeah.
He's not stuck to just using Tyvek on all his homes.
And he's very knowledgeable of them, and it seems that he
takes pride in that.
Yeah, he takes pride in his work.
Yeah.
For sure. Especially with a home like this one, because when you're using this reservoir cladding, it's going to last a long time. The exterior is, so it's hard to replace. You're not going to be replacing that as often as you would replace a vinyl siding or something.
Yeah. So here he's showing how, because they built up the outside of that wall after the sheathing, they have to use a special type of screw.
Mm-hmm.
So
an anchor that goes all the way into the stud, because you have that 2 inches of mineral wool insulation. Yeah, and then you've got that dimple mat and a 1 inch air gap, and then your stone.
So even the ties that he's using, the brick ties, they can't just be the normal brick ties.
Yeah,
I think they have to be some extra long ones.
Yeah. What are those flimsy ones made out of? Is it just
probably some aluminum thing?
It looks like it.
Yeah. We'll see that in the next video. He's using these hardcore.
Yeah, these more heavy duty ties.
Yeah. Okay, now he ends the video just talking about how his stone guys have done such a good job on the outside, and how they actually hid the lintel over the window. You can't even see it. And they did that by actually placing the lintel above where it needs to be, right? Right there. So they basically used 2 lintels, didn't they?
Mm-hmm.
Yeah. Just to relieve the pressure over the window, I guess.
Yeah.
It's a very expensive, complicated, labor-intensive thing.
Labor-intensive for sure.
But they say that it adds a lot of value to your home. So
yeah, that's true.
if you go to Preston Hollow or any of those high-end homes around your Highland Park, what types of cladding do they use in their homes? Is it brick and stone mostly?
Mostly, yeah, brick and stone. I mean, that's
But the modern homes, they don't. They use stucco on those.
It seems to be the most common material, especially in the DFW area. And often that is because the building code or the city ordinance requires that you have X amount of masonry, a percentage of masonry on your facades.
Yeah, but I'm saying that the modern homes in the Preston Hollow area, the contemporary homes, those are all usually white stucco, right? They don't use stone.
They're always experimenting with different materials.
Yeah, so are they cheapening their home by using that instead of brick or stone?
Well, by making it modern, I guess they're appealing to a different customer.
Yeah, that's true.
And sometimes they'll use like a solid concrete wall or something, which is masonry in a sense.
So some codes specifically say that it needs to be a masonry cladding excluding CMU block or concrete.
Which we like CMU block.
Yeah.
Why do we like CMU block instead of
Because we were taught to like that in architecture school.
Because it's big. It's big and thick.
Monolithic.
Yeah, monolithic.
Yeah.
It can serve as a wall in itself, as opposed to brick. It can't.
It's just
it would get too wet.
Veneer. Yeah. So related to that video, since Matt Reisinger loves building science so much, I found this.
Oh, the website Building Science.
Oh no, he calls himself an expert at building science.
Oh, okay. I thought you were saying since he likes buildingscience.com.
Oh no, he's a building scientist.
Okay.
So this website shows how brick claddings work, how air moves behind the brick cladding. And you have to make sure that there's a weep hole at the bottom and a weep hole at the top to allow air to move behind it to let the water evaporate, because water is going to get through there either through just going through your grout or through your brick, or it's going to get through capillary action. So you have to make sure there's at least a 1-inch air gap, right? Is that a minimum?
A minimum 1-inch air gap, yeah.
Yeah. And they also talk about having a drainage plane and a drainage space. So in this example over here, there's 1-inch drainage space, which is, and the, I guess the Tyvek or something behind it, that acts as drainage plane.
Yes.
Yeah.
Yeah, the water's going to shed off of.
You see the brick ledge on the bottom?
Mm-hmm.
How many of the houses actually use that, and how many just have it sitting on metal? I mean, that's the smart way to do it, I think.
You can do both. You can put it on a metal lintel, or you can have a brick ledge.
Yeah.
It seems like if it's an afterthought, you have to use the metal lintel. Or if that's the look you're going for, I guess, give it a more floating look, as opposed to it being more monolithic when you have the ledge on your slab, the brick ledge for your slab.
That's a good point.
And so this is an example of a drain cavity with a really small airspace, and that's because they're using an impermeable rigid insulation on the exterior of the house, and thus that's where all water is going to stop. Nothing's going to go through that, and so the air gap doesn't have to be as big, but it's the same in the sense that it has, I guess it doesn't have an outlet on the top, a drainage outlet on the top.
Yeah. So that would be like an insulated zip R sheathing?
impermeable, rigid insulation.
Yeah.
Well, Zip has a perm rating of, what, 11 to 16, so water's still, condensation is
true.
still going to get through.
So
Sorry,
what would
vapor
be...
is still going to get through.
So
But
what would be an impermeable rigid insulation?
like an XPS,
Okay.
XPS foam.
Or polyiso on the
Yes,
outside?
yeah.
But Zip uses polyiso on their sheathing, but it's on the inside, you're saying? So
If it's our sheath, yeah.
Okay.
Yeah.
Got it. So what if you flip your Zip system?
I think
it's
that would
meant to
defeat the
be used
purpose.
that-
Yeah. Yeah. So I mean, I don't know why you would install, if you're going to put brick on your facade, I would think put a 1-inch air gap just to be safe because of how much, I mean, Matt Rissinger talks about how the brick facade can carry multiple gallons of water.
Yeah.
So
Soaks it up and throws it and dumps it behind
it's better
it.
to be
Yeah.
safe than sorry. I would not skimp on the air gap.
I just thought about this. Homes nowadays are built with both brick and stone because they don't want it to look monotonous. So we just visited a house this afternoon, and on one half of the house they're going to be using brick, like a reddish brick. The other half's going to be white stone.
Mm-hmm.
But the thickness of stone is much greater than brick.
Yes. So they're going to have the air gap for the
Brick
but
and not for
as
the stone.
big of an air gap for the stone.
Or nothing at all.
Yeah.
Yeah.
And why is it you don't need an air gap for stone, but you do for brick?
Stone just doesn't let as much water through as brick does.
Okay.
So maybe that's why that's the excuse. But like Matt Reisinger was saying, if you're going through all this trouble to custom cut each piece of stone, because that's done on site.
Mm-hmm.
Like brick is pre-cut, you just chisel some pieces. But with stone, you have to make sure it fits in.
Right.
And if you're going through all that trouble, make sure it's installed properly. Just have a 1-inch air gap behind there.
Mm-hmm. So this video is it's an older video, as you can tell by the aspect ratio,
Yeah.
but it's just a basic installation of brick on a facade. And right now they're mixing up the mortar and they're showing how they install. They lay all the mortar, set the brick, wipe it off, clean it off, rinse and repeat for thousands and thousands of bricks. And they're showing the 1-inch air cavity that you have to have.
See all that mortar stuff behind there?
Yeah.
Oh.
I mean, these guys look like they know what they're doing. They're installing pretty quickly and very cleanly, but it still gets messy behind. So having that
At least a 1-inch air gap,
is critical.
Mm-hmm. They dump so much mortar between courses and then just squeeze it down. So some of that mortar goes up through the holes in the brick, and that kind of secures the brick in place. It's essential to actually have that much excess mortar for the squeeze out.
Which you don't have on the stone.
Which you don't have on the stone. That's true. Wow. So does the building code require extra ties when you're using stone? More closer space ties or anything?
I'm not sure. I think they lump brick, veneer, and stone together. So in this section, they're showing another one of the most crucial parts of installing a brick facade is that you have to have your flashing done properly, intermittently, as you're laying your brick, like under your windows and such, so that the water can shed off, because their water will get back behind those bricks.
Good old-fashioned 15-pound
paper. That's what's on our house.
Tar paper, yep.
Yeah, like I said, old video.
Old video. So
But
now they just use Tyvek once behind there and that's it, they're done.
Right.
And then they just put a continuous sheet of, continuous layer of brick. I don't think they even put intermittent flashing anymore.
So you have that 1-inch cavity behind your brick or your stone. And another way for the moisture to escape is by using weep holes, which he's installing a weep hole right here. It's a little plastic piece that he's putting between the bricks.
So you can either just leave a gap or you can put that plastic piece there.
Yeah, and just don't fill it with mortar or else you're defeating the purpose of it. But yeah, those weep holes are crucial to allow the water to escape because, it may drain to the bottom of that air gap, but where's it going to go after that? It needs a way to escape. So you typically have these, according to code, 33 inches on center, the weep holes, and they're above your first course at the base of your brick ledge.
And then even on the top sometimes, right? The topmost course? Because that's what we have at our house.
Or you'll have a way for the air to escape up into your soffit.
Yes, yeah.
So here's those flimsy brick ties that are used that just sort of hold your brick barely to your house. I mean, mortar is just a...
See, here's the big gap between architecture and construction, and it frustrates me. Like, whenever you're building this in Revit, you're just changing the pattern on your wall from solid to brick, and that's it. You're done. Like, 1 inch air gap, that's it. But when I found out that all brick walls are basically independent and they're just tied to the main wall by these tiny... It blew my mind, because I thought it was an integral part of the full wall. It was one system.
As architects, we learn to hate decoration on homes, and unfortunately, brick is pure decoration.
Yeah, that's true.
So here he's showing how you would install a sleeve for your electrical or your plumbing that's coming out of the building.
And then put on brick on either sides of that.
Yeah, and you have to cut that's when you'd have to cut the brick. And they're installing more flashing for under the windows, very important.
And here there's a 2-inch minimum dam feature. So that's to make sure that any water that goes underneath that windowsill escapes right at that point. It doesn't go underneath that through the wall and
diverting it back into the air.
Outside, yeah.
Yeah, away from your windows. Windows and doors, all your openings. You just have to have extra flashing and be very careful.
Lots of air bubbles in that flashing. Is that an issue?
Oh, yeah.
They didn't really care about that.
That's true.
Gosh, it's so labor intensive.
Mm-hmm.
Each brick put on one at a time.
Yeah.
I used to think, there's another misconception. I used to think that was a panel that's just slapped on the wall.
Yeah. I'm sure they have those.
Yeah, but panels. Those are the veneer. Those are really thin.
Yeah, this is an actual piece of brick. Yeah. I mean, this is keeping a lot of people employed.
There is an art to it. I mean.
Oh, yeah, definitely. I mean, it seems very therapeutic. So here they're setting the brick sill, which is actually at an angle to divert water away. And so they'll set a layer of mortar and let it dry. Thicker or built up more in the back, and so that they can place the brick at an angle, and so it diverts the water away.
So it's the same brick that they use the rest of the wall. They just rotate it in.
Yeah. So now we're going to get into a little bit more of the graphic details of how the brick is installed. So here you'll see here's a 3D model of where your brick ledge is, and this is shown that this looks to be a rigid insulation behind it.
So there isn't much of no air gap, like maybe half inch,
a small
quarter
air gap
inch
for this.
Air gap, yeah.
And then you have your WRB and your sheathing behind that. So you need some sort of flashing. They'll use the black grade D paper that comes down to the bottom.
Well, actually, no. It's a plastic, I think. They don't use They used to use that paper-based product for a little while, but it disintegrates very quickly. And just think about it. That's the bottom of the wall. That gets a lot of water.
Mm-hmm.
Everything going behind the brick is hitting that. So they quickly realized that using paper-based products as flashing behind at the bottom of your brick wall was a terrible idea. So now they have a steel alternative.
Stainless steel.
Stainless steel alternative. Mm-hmm. They also have plastic, which is the house that we visited today. That uses plastic.
Plastic's going to be a lot cheaper than a stainless steel method. But so all that water is coming down to the bottom, and it's getting trapped at that brick ledge, so it needs the flashing to divert it out, and then the weep holes allow the water to actually escape.
So this video I found is also animated, and that's a SketchUp model, but it's slightly different than anything else I've seen, and I don't know if the guy who's narrating it is Australian, so I don't know if this is how they build it in Australia.
Yeah.
And it could be that case. I mean, everywhere around the world they build differently, but they use the mesh after their first layer, and you were saying that's maybe because to catch any motor that drops down there.
Yeah, it's sort of filtering out everything, allowing all the water to go to that bottom course and then escape.
But he uses that right over it. It's some sort of
flashing as well.
Yeah. So isn't that a barrier for nothing to go below?
I'm not sure why he's using that.
So here's another flashing detail. This is at the windowsill.
Yes.
Brick sill.
So here's a good detail of the brick sill. it's showing how they cut the brick, they set it at an angle, and they build up that mortar behind it.
So they had to cut each of those bricks individually at that angle.
Yeah. So here we're back to a video by Matt Rissinger, and this is an example of how brick was done, installed incorrectly. It's a home from the 1950s, and so he's ripping it all out. And
I think they use stone. You see all that stone behind him?
Yeah. Sorry, using a reservoir cladding.
Yeah.
So this is how he discovered they installed it incorrectly, and so he's going back and having to fix everything down to the sheathing, and then put the stone back on. Not the same stone, but put new stone.
Forget the sheathing. You have to remove the studs too, because all the studs were
That's
rotten.
True, yeah.
So he says that not only rain, you have to think about the sprinklers that in your garden too.
Yeah, constantly battering your walls with water, your shrub sprinklers. And so you have to think about all that water hitting your brick. And
this house didn't even have gutters in the front.
Oh, okay.
So all the rain was hitting that wall.
Yeah. Not to mention the sheathing that they used, which is not so commonly used nowadays, but it was gypsum sheathing or drywall.
Why would you do
Paper-based.
that?
Come on.
It's like they go through the building construction industry goes through cycles like, hey, this is a new product. Maybe this will work. Nope, that failed. Let's go back.
Yeah.
Oh, come up with another product.
And so in this example, he explains how the brick got so wet and it soaked back into the wood, and the wood attracted that moist wood attracted termites.
Yeah.
And caused lots of internal damage.
And the paper-faced product definitely helped. So all these white marks, that's all termite damage.
Yeah.
On the front and the back.
Where they're burrowing in. Yeah.
And you can see these lines in the wood, and that's just carved out by termites.
Mm-hmm.
So he's saying in another part of the house, they had a renovation.
Yes.
And over here, they used OSB instead of the gypsum sheathing. But that didn't fare well either. You can see all the rot at the bottom of that wall.
Yeah, their flashing detail must have not been very good because the water was able to sit on the OSB, caused it to rot out.
It looked like there was a sheet of remains of Tyvek right there. Do you see that? There.
Yeah, on the renovation part, it looks like.
So I wonder if they used Tyvek on the gypsum board part, the older part of the house, or just this part?
Well, if it was built in the 50s, Tyvek wasn't around back then.
That's true. So they just had it. Maybe they didn't even have felt paper.
Yeah.
Yeah. So he goes to another part of the house where he's cut out a big portion of the Tyvek and the OSB and revealed the back side of the stone. And what he's going to do now is he's going to spray water on the front side of the stone and show in just 45 seconds how much water is absorbed by the stone and passes through to the back side of it.
Yeah, you can see it leaking right through. And
that's crazy.
Yeah, if you haven't planned correctly, your WRB isn't sufficient. That's going right there and just sitting on your wall.
So why don't they have an air gap when they're installing stone? I mean, it seems just as porous as brick.
Mm-hmm. I wonder if it's because of the non-uniform nature of stone. It's hard to get a consistent air gap.
Because you're chiseling out each part of it, like you can see over here. So the damage was so extensive over here. You can see all the OSB at the bottom is rotten. There's a pressure-treated wood right at the base too. Even that is rotten. And that's supposed to endure a lot of water.
Right. But this was just too much. As you can see the water leaking right through. And that was just him spraying it with a hose. So think about all the times your sprinkler's on hitting your wall, and hope you have it your WRB installed properly behind it, and your sealing details, your flashing details. So brick is a material that it looks really nice and it's very durable.
And adds value to your home.
Yes, it makes it seem very sturdy, very solid.
Yeah,
well built. But it is just decoration. It's not truly what is keeping your house together. As we discussed in previous videos, that's about the framing, the OSB, your weather-resistant barrier, all that stuff.
Exactly.
Those are the most crucial parts of your home. What's on the outside is all just decoration.
Yeah, it's not structural at all. It's not keeping water out. It's not keeping air out. It's not keeping moisture out. It's just a cladding.
Mm-hmm.
It's a permeable cladding. It's an expensive permeable cladding.
Yes. Yeah. So why would you use a brick if you weren't required to?
If not by code,
Correct.
if not required by code.
In our opinion, you wouldn't.
No,
We're not.
Definitely not.
We think it's way too labor intensive, and it's also not DIY friendly. As you can tell, those masons are experts. They've been doing that for a long time.
Yeah.
I mean, we could attempt it, but it would probably be pretty messy.
Yeah.
So we're much more keen on using a more modern siding, like a wood rain screen or a metal siding or something like that.
Exactly. And something that can be replaced pretty easily if something goes wrong. The big issue with brick and stone is that it has such little room for error, first of all. And if something goes wrong, if there's a crack in the mortar, if your brick cracks, if something fails, you have to tear down that entire wall. It's a whole system.
Yeah, and good luck getting a brick that matches
something
that same
old
brick.
and new.
Yeah.
Well, but with the wood rain screen or something, you can just replace a plank. Well, I say that, but then you've
good luck matching that rain
good luck
screen.
matching that too. Yeah, exactly.
Matching that wood. But oftentimes, what a lot of people will do is if they do repair cracks or things like that, they'll just paint their brick.
Yes.
And that's a problem in itself if not done properly.
Mm-hmm.
So if the wrong paint is used, it creates an impermeable layer. But as we've seen with any building product, it's never installed 100% correct. So there will be ways for water to get in. And once it gets in, it won't be able to get out.
Because the paint prevents all that water behind the brick from
Right.
getting out.
Like we mentioned in a previous video, latex paint's perm rating is sub 1.
Yeah. And imagine if the paint clogs up those weep holes at the top and bottom of your wall. I mean, if someone just paints their wall themselves and like, oh no, there's a hole right here in the wall. Let me close that up.
I think those are important. Those are supposed to be there.
I mean, you have to know what you're doing and you have to use the right paint.
Yeah.
And there's this obsession right now with painting brick. Even on our street, at least 3 or 4 houses.
Painting it white.
Painting it white.
Specifically.
Yeah. And first of all, that white paint doesn't last very long. You can see some of the homes that were painted maybe 3 years ago, they don't look that good. Yeah. And then in Texas, with all the clay soil around here and all the shifting that happens, having something as solid as a brick wall that is very unforgiving, or a stone wall.
Yeah, we have firsthand experience with that because our house needed foundation work right when we moved in. And when we
were actually really fortunate because there was a massive 1-inch crack in the drywall right here. And I say we're fortunate because on the other side of this wall is vinyl siding.
Yes.
We have brick on this side, vinyl here, and brick on that side. And the point where the crack happened was exactly where the vinyl siding.
Yeah, that could have been a massive crack in our brick, and we would have had to clean that up and paint it to make it look good.
Yeah, we got lucky with that. But there are plenty of cracks in the front.
Yes, and when you repair them, they never look the same.
No.
I mean, you can tell it's been cracked.
Mm-hmm.
But there's other materials that, in our opinion, are more forgiving, easier to replace, more DIY friendly, and we'll discuss those in a future video.
Yeah.
So that's all we have for reservoir cladding. Thanks for joining us.
See ya.
Bye.
Hi.